Let me start. So thank you very much. I'm Hiroki Akamatsu from ESROM, the Netherlands Institute for Space Research. Here I will talk about this title. It's a bit complicated, but you can see is this beautiful Meerkat radio image in purple. And I have a quite a nice collaborator listed here. If you find any mistake in my talk or unclear point, that is to me. And if you find any interesting point, that is for my collaborators. In particular, I will talk about this paper in this recently published in Nature. There are 3 corresponding authors. One is James Chibed, who performed Meerkat observation, and Haruka Sakemi, who read the radio data analysis, and Takumi Omura, he dedicated this numerical simulation for this space object. And okay, so this is a really great conference, and SOC list up several objectives of this conference. And those objectives I will contribute to this last part. What new facilities are needed to advance the study of cluster and proto-cluster assembly? I will contribute by showing the capability of Meerkat telescope, that is a state-of-the-art radio telescope, and to show some one example of a role of magnetic field that can be opening Pandora's box, but let's see what we will see. So let me remind you the whole energy dissipation process in the cluster of galaxies that my preferred plot that was made by Professor Khan. And during a cluster merger, the gravitational energy released by shock to the heat and also particle acceleration to here. And those shock also can generate turbulence. And this turbulence can amplify magnetic field and accelerate electron and cascade down to the heat. In this conference, there are so many relevant talks and posters, but let me emphasize, so these are my vicinity researchers, and there are quite nice posters, and please have a look also this gather town. And again, I will talk about this cluster magnetic field. And if we talk about this cluster magnetic field, one example is cold front. I don't need to repeat the definition of cold front, but just remind you the structure here. This is Abell 3667 observed by Chandra, and you can see clear surface brightness structure. And this across this structure, we can derive X-ray surface brightness, and it's clear around this cold front, cluster plasma is deviate from ideal condition. So the conduction is suppressed. People think about presence of magnetic field, and if you think about that is the magnetic field, expected value will be around 10 plus minus 4 microgauss. And similar value are also reported in the other objects. So after findings of this cold front, many efforts are devoted to explain this structure. In particular, the quite nice review by John Zuhon that may be nice to have a look on that. But most important outcome, one of the most important outcome is around the cold front, plasma beta can be close to 1. So plasma beta, thermal and magnetic pressure. So around that time, we cannot ignore contribution of magnetic field. Okay, now get into the target. I will talk about, sorry, it's nearby cluster, redshift of 0.046. This is a merging cluster Abell 3376, reported by Bakch et al. And you can see elongated X-ray morphology and radio emission. And you can see a lot of detailed investigation by different wavelengths. To explain this elongated morphology, Machado et al. Perform simulation. Come on. Yeah. So to explain this observed X-ray morphology, they need 1 to 4 1 to 4 mass ratio and rather small the impact parameters. So, and later on, our PhD student, Igone Urlampiretta, confirmed the presence of cold front at tip of this subcluster. So that's kind of natural because this subcluster penetrating the main cluster, and most of the things is stripped out. But in parallel, what interesting things is from this Bakshi et al., it is clear this second brightest cluster galaxy, second BCG, generating jet. But that jet is bending toward direction of the cluster, the moving direction. So we want to understand why this is happening. What is the root cause of this rather non-usual radio bent radio the galaxy? So that's the reason that motivate us to propose the Meerkat observation of this cluster. This is a Meerkat image. You can see a lot of interaction between the cluster plasma and also radio emission, but I will only concentrate now central radio galaxy highlighted by square, white square. So this is a Meerkat image of central image. So you can see more detailed structures. And first things I need to say, this jet suddenly bend almost 90 degrees. And another small thing is this jet is still collimated over the 100 kiloparsec. Typically, like you can see in the source B, after the bend jet will be blow up, like explained by our golden marks on the top. And another last one, it's rather shallow, but we can see shallow emission in the anti-jet direction around here. So whole three is completely different from typical Watts object. So we want to understand again root cause of those emissions. So thanks to the wide frequency coverage of Meerkat, we could derive in-band spectral index. So they have about 800 megahertz coverage, or maybe, sorry, 900 megahertz. And we can divide into the frequency and calculate spectral index from one observation. So left-hand side show the spectral index 2D map, and let's concentrate for north part, that is more clear. And the right-hand side, we show the spectral index and also flux density as a red. At the N1 region, you can clearly see electron is cooling down after injected by AGN. However, at N2, in particular, where jet bent, the flux, radio flux suddenly jump up and spectral index getting flatter. At N3 region, those property back to normal again, cooling down. So here, something happened. In particular, this means energy injection to the relativistic electron. So this energy injection, we need some physical process. And the physical process in the cluster of galaxy, we want to see the plasma property. That's the reason we start to investigate X-ray observation. This is an XMM image together with the Meerkat radio controller. And we extract the radial profile as shown in the right-hand side. You can see here is a cold front. The originally already reported cold front here, but this one reconfirmed cold front still extend down to this radio jet region. So around there, we would expect still strong magnetic field. And interestingly, this radio emission also has a peak at the location of the cold front. This is the observational evidence and interaction between the AGN jet and cold front. So, but again, this is just observational result. To understand this morphology, we perform the numerical simulation based on the Asai et al. So we modify Asai model to explain this specific object. And this is a mock model. And you can see the magnetic layer in the here, like arch-shaped magnetic layer. To this layer, we inject AGN jet like this. So once, depending on, of course, depending on jet power and also magnetic tension, but if those two are balanced, the magnetic tension can deaccelerate the jet speed and can make this T-type shape type of structure. That is one of the most important things. In this Abell 3376 case, about 10 to 20 microgauss magnetic field is required. Yeah, thank you very much, Tony. Okay, so this is a slice of the simulation, and yellow line indicate the cluster magnetic field line, and the bluish color indicate jet speed. So blue, light blue indicate rather fast, actually red side, and blue, dark blue indicate rather slower. So meaning around this magnetic layer where interact, the jet speed deaccelerated due to magnetic tension. And right-hand side showed 2D image. So from this image, this plot, we could also explain this rather elongated N2 region and N1 region. I couldn't include explanation of N3 region, but that is a reaccelerated electron could flow following the magnetic field because they are cold front. So this is our simulation. So from this three evidence, radio observation, X-ray observation, and this dedicated numerical simulation, we claim there are interaction between jet and intercluster magnetic layer. So this is my summary. I am back to the contribution to this workshop, conference, capability of new facility. Here I show you the one example of Meerkat. So Meerkat reveals interaction between AGN jet and intercluster magnetic field. And actually this interaction was already predicted at 1996 by a theoretical people to explain, to keep cool core. And important things, so how it's important is this magnetic field in cluster, of course, cannot be ignored. And in this particular case, energy transfer efficiency of the AGN feedback might be enhanced by this intercluster magnetic field. So this may have a more impact on the AGN feedback efficiency side. So last but not least, so I would like to thank for SOC, LOC, and the participants. And I'm quite happy to discuss furthermore. Thank you very much.